Chapter 3, Sets. So a set is a collection of distinct objects called the elements of the set. A set can be defined by describing the contents or by listing the elements of the set, enclosed in a curly brackets. Okay, so some example of set defined by describing the contents. For example, I can say you have a set of all even numbers. Okay, so that means 2, 4, 6, 8. Okay, and etc. Or you can say I have a set of books that's written about traveling to Chile. And example 3.2 is an example of sometimes we can describe it in words, or you can simply list them out. For example, I have an element I have a set with the elements 1, 3, 9, 12, or I have a set with the elements red, orange, yellow, green, blue, indigo, purple, also known as the set will be the color of the rainbow. Okay, so notation with sets. There are many notation we need to know. Now, the first notation we're going to learn is this E looking thing. Okay, now that symbol means it's an element of or a member of. For example, if A equal to A, B, C, D, E, F, okay, then we can say, well, A, B, C, D, E, F are the elements. And then we in part B I wrote A, B, C, D, E, F is an element of set A. Notice usually we put set as a capital letter, okay, that and then we can use pretty much any letter we want. Okay, so in this case we have A containing all these letters, or we can say all these letters is the elements of the set capital A. Now a subset. So subset is a small set belong to a larger set. So for example, if I have a set A equal to 1, 3, 5, set A might be a subset of what larger set. So we can say, well, set A belong to a set with all R numbers. Or if you look, 1, 3, 5 definitely belong to all R numbers. Or you can also say set A belong to a larger set, all real numbers. Okay, so therefore A is a subset of the set all R numbers. Or you can say set A is a subset of all real numbers. Union. Now, what union is, so the symbol is U. Okay, so union is when a union of two sets contains all the elements contained in either set or both sets. For example, if we let's say A equal to orange, yellow, and red, set B is orange, brown, and purple, and set C is pink, brown, red, yellow, orange, and purple. Find A union B and B union C. Now, A union B means I'm gonna combine all the elements inside A and B. So let's see, we have orange, yellow, and red. Now notice B has orange, but we don't have to say orange again. If you have orange already once, you don't have to say orange again. So then we continue. Now this actually inaccurate, right? So if you combine these A and B, it should be only orange, yellow, red, and brown and purple. Okay, there's a typo here. There's no blue, there's no green. Okay, now B union C, same thing. If you look at between B and C, what are all the colors that B and C contain? Right, so all of them you have what? Orange, brown, purple, and then you have the pink. Now we don't say brown again because we already mentioned brown when we list B. Then we have the red, yellow. Now we don't say orange again because we already have orange, and then we have purple. Okay, right. So do apologize for the typos in here. Right, now intersection. Intersection is the opposite. Intersection is actually not what both of them. You don't want all of them. What you want is what both have in common. So again, this there's a typo when we type this up. So for example, if A and B, you want the intersection of and C. So the first thing they want is intersection of A and C. Now if you look at A and C, what do they both have in common? They both have orange, they both have yellow, and they both have red. And that's the only thing they have in common. So intersect is what do they have in common. Now, so it's orange, yellow, and red. Now, the second example, B intersects C. If you look at B and C, so what do both of those sets they both have? They must both have, they both share. So they both share orange, they both share brown, and they both share purple. All right, so that's intersection. All right, last but not least, complement. Now, what a complement is if I have a set A, a complement of A will be what's not in A. What is not in A? Okay, so let's do an example to see how this works. So, for example, if A is 1, 3, 5, 7, and 9, and B is 1, 2, 3, 4, and the union, now this U right here is called a, here I'm putting it right, it's called a universal set. Now, universal set is the larger set that, that set A and B both belong to. Okay, so if you look, so how do you find a complement? Okay, now a complement means, okay, A is 1, 3, 5, 7, 9, but take that set compared with U. What is missing? U is 1, 2, 3, 4, 5, 6, 7, 8, 9. A is only 1, 3, 5, 7, 9. So the complement of A, or AC, is 2, 4, 6, 8. Is all the other number that's not mentioned in A, but it's in U. Now, the second part is easy. We're going to intersect with B. Now, we just simply list B. So if you intersect those two, the answer is 2, 4. So complement is what is not in the set that's mentioned, but in the universal set. Okay. So here it is. Now, what's the universal set again? So a set of books, okay, so that equal to what? All the books in the library. Now, that all the books in the library, all the books in the library is the universal set. So be a set of friends on a social media, and all, like for example, the universal set will be all the friends on Instagram. So just think of the universal set as all the possible items that can be in that set, or all the elements that can be that set. Okay, like a set of numbers, if the universal set will be what? All real numbers. But all real numbers contain a particular set of numbers. So here's another example. Okay, suppose the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. If A is 1, 2, and 4, what is a complement? A complement is anything that's not in A but in U. So since A is 1, 2, and 4, A complement will be 3, 5, 6, 7, 8, and 9. Okay, now here's some example of the combination if we combine all the notation we just learned. So let's look at example 310. Let U be the universal set where U is equal to 1, 2, 3, 4, 5 all the way to 20, and then set A is 2, 5, 7, 8, 10, 11, 12, 15, 16, and 20. And B is 1, 2, 3, 6, 7, 9, 11, 14, 16, 19, and 20. So find the following. Part A intersect B complement. Now A, we just simply list out A. Now we have this intersect. Now we need to find the B complement. So we need to take a look at B. Well, how is B compared to U? Because B complement means list all the number that's not B, but it's in U. What missed? What did B missed compared to U? So 4, 5, 8, 10, 12, 13, 15, 17, and 18, those are B complements. Now the intersect means what do they both have in common? In this case, 5, 8, 10, 12, and 15. Okay, here's one more example. Let's let's do this so we can see the original question. Now part B says B intersect A complement. Now this one is the reverse, where we list the B out first and then we intersect A complement. So we have to go back and look at the original question. A is this set of number 2, 5, 7, 8, 10, 11, 12, 15, 16, 20. A complement will be all the other number that's not mentioned in U but in A. So it's not A basically. So 1, 3, 4, 6, 9, 13, 14, 17, 18, and 19. And their intersection, that means what do they both have in common, will be 1, 3, 6, 9, 14, 19. Now remember, when you list out all the elements, you have to remember to use brackets. Okay, so chapter 3.3, Venn diagrams. Okay, now sometimes if we don't have a specific set, we use Venn diagram to show the same result. For example, what's A union B intersect C complement? So if when you do something like this, you start with I will start with the complement, right? So the C complement means, so imagine, so in this particular exercise, it helps if you have different color pencils, okay, or pens. So when you have three elements, you usually draw a circle like this, where you have A intersect with B with a C. Make sure they they overlap each other. Okay. Now, if you look at the last one, it says C complement. Now, C is this white circle right here. This is all the C, right? Now, C complement means what? Basically, you're supposed to color everything here and just skip this circle. That's C complement. Now, and A union B. Now, where's A union B? Now, A union B, it's just, if you think of A union B means I want entire A, entire B, right? So all the A will be here, all the B will be here. Now, if you just draw A union B, should be, these both circles should be darkened. But we want to intersect the C complement. Now, remember, C complement is anything but this circle, right? Okay, so it's everything else. So if you look, what's between these two circles and everything else, right? The intersection part. Now, so the only part, if you overlap each part of this equation or this notation here, the only thing that will be overlap by with all the colors overlap each other is this section here. So the ending result is this, where this. So what display here is not a work, but it's more like the ending result, what the Venn diagram should look like. Okay, so cardinality. Now, this basic is saying that how many members are there in the elements if you're counting them up. Okay, but we use this mostly to do application problems. So let's take a look at this. Okay, for example, a survey of 200 people are asked, what beverage do you drink in the morning? And offer choice are tea only, coffee only, or both tea and coffee and tea. Suppose 20 people reported they drink tea only, 80 report coffee only, and 40 report both tea and coffee. How many people drink tea in the morning, and how many people drink neither tea nor coffee? All right, so there's only two elements here, so it's not like the three here. We draw three circles. We just need to draw two because it's just between tea and coffee. Now, again, when you draw anything with sets like this to work on any problem, you need to make sure they overlap each other. So there's the area where you can have the intersection. So we always start with this kind of type of question with where the intersection is. The intersection means both. So if you look at the question, looking back, 40 people, so 40 people should go in here because 40 people drink both tea and coffee. So we got 40 already set. Okay, now, rest of the question is a little trickier. So if you think about this, you say, okay, 20 people report tea, okay, tea only. So look where 20 people is, that's tea only. And 80 people report coffee only, so 80 people goes here. So we have all section of it. Now, this 60 is not given to you, but we know that because 200 people was asked, so this entire thing should have 200. So if you add all these numbers up and you subtract from 200, that's where we got the 60. So the question is, how many people drink tea? Just looking at the Venn diagram now. Well, if you look at all the tea circle, it's like 60 people. And how many people drink neither? Okay, then that's the 60 people that's outside, not including in both of these circles. Alright, here's another example. Suppose set A contains 48 elements, set B have 56. If set A and B have 25 in common, what's the total number that's not in neither in set A nor or set B? Now, again, start with the middle. Okay, so middle is 25 because they're both in common. Okay, now how do we figure these two out? Now this one's a little different. Last ones they give you what's in the A only and B only. This one you have to figure it out. Now we know if you start from the question, it says set A has 48 elements. Well, imagine this whole circle has 48 elements. Since 25 is already taken in the middle, so if you take 48 minus 25, that's how we get 23. So 23 is A only. Now, we're going to find a B in the same way. If you take 56 minus 25, that's how we get 31. Right? So once you have all these numbers, and then that's how you figure it out, right? Okay. So what's total number of elements in either set A or set B? So we add up all those numbers, 79, or you can use the formula. But if you just simply add them up, you just get 79. Okay. So same thing here. There's now this question right here is if you use a formula. So if you use a formula like this, okay, so you know what you need to add up. You add up the two number and then subtract the common. Okay. Same thing here. If you add up these two numbers and then you add up what do they both have in common, that's 25. That's simply using the formula. So it's up to you. You can either use a formula or you can use a Venn diagram. Okay, same thing here. You have the 2, 13, 56. because, well, if you always find what's in the middle first if you can, or if not, we can. Well, I would like to go over this one again. So how would you?